first theorem is the remainder theorem. Okay, when you say remainder theorem, if the polynomial piece of x is divided by the binomial x minus r, the remainder r is a constant and is equal to piece of r. Or in other words, we simply need to evaluate the equation using the value of r, which is the constant found in the divisor, and we can eventually find the remainder of the polynomial divided by the binomial. So to understand this theorem, we need to apply this in an example. So let us discuss the first example, which is dividing the polynomial. So the given polynomial represented by piece of x is equivalent to 2x cubed plus x squared minus 8x minus 4. So this is the polynomial containing 4 terms. First term is 2x cubed, second term is x squared, third term is negative 8x, and then the constant or the last term is negative 4. The polynomial is arranged properly, descending order. The first term has the highest exponent, 3, second term, 2, and then the third term, 1 exponent. The last term is 0, x raised to 0. That will give us the constant negative 4. And then the divisor of this polynomial is the binomial x plus 1. So to find the remainder, in order to find the remainder of this polynomial divided by the binomial, we need to apply the remainder theorem, which gives us the first step to first identify r. R is the constant found in the divisor, in this case 1, and we need to always use the opposite sign of this, because from the form itself that x minus r. Therefore, if the sign is positive for the given problem, we need to express it as positive. If the given is not positive, we need to express the negative sign because of the fact that we need to express this at negative 1 in order to get positive 1. Because from the original formula, we have negative r. So negative, copy negative sign here, and then we need to use negative 1 in order to get positive 1 from the original problem. That's the reason why the sign changes. From positive here, we will use negative 1. Or the easiest way to remember this is that every time we use remainder theorem, just like in synthetic division, we always change the sign of the divisor. Now let us proceed with the solution to find the remainder. So we will now write piece of, we are evaluating using the value of x as negative 1 equals all variables here in the polynomial, the dividend, will be changed to negative 1. So we will write 2 times negative 1 cubed plus negative 1 squared minus 8 times negative 1 minus 4. Then simplify or solve the equation. We need first to apply the exponent before you multiply. Okay, the rule states that exponent first before multiplication. So copy first 2. Do not multiply 2 and negative 1. You need first to simplify the exponent of negative 1, which is cube, which means negative 1 times negative 1 times negative 1, which will give us negative 1. Then, negative 1 squared is positive 1. Okay, take note of this. If the base is negative and the exponent is odd, the result is always negative. If the base is negative, the exponent is even, the result is positive. Multiply two negative numbers, the product is positive. 8 times 1 is 8. Simply copy minus 4. Continue the solution by simplifying. Multiply the two numbers. Opposite sign will give us negative 2. And then plus 1 plus 8 minus 4. Okay, we are now going to combine 4 signed numbers. To easily get the final answer, you need first to combine those numbers with common signs. Therefore, you need to combine first 1 and 8 in order for us to avoid error in the signs. combine first two positive numbers, 1 and 8, which is 9. And then combine also the two negative numbers, negative 2 and negative 4, negative 6. So that we can easily find the final answer, which is 3. That is the piece of negative 1. And it can also be written as R, uppercase R, which is 3. This gives us the answer that the remainder is positive 3. I need to place here a small box that will contain the divisor. Change the sign, just like how we apply the remainder theorem. From positive, we use negative 1. Then copy the numerical coefficients 2, 1, negative 8, negative 4. There is no missing term. There is no missing term. The terms are complete. So 2, 1, negative 8, negative 4. I will place a line here, then bring down 2. Multiply 2 and negative 1. The product is negative 1. It will be written here in the second row, second column. Add. This time we will add instead of subtract because we already changed the sign of the divisor. Add negative 1. Multiply again. Repeat the method. Negative 1 times negative 1 is positive 1 right here on the second row, third column. Add negative 7. Negative 7 times negative 1, positive 7, right? In the last column, add 3. Okay, so the last number here is the remainder, 3, which is the same answer that we obtained a while ago using remainder theorem. This is the quotient, but we don't need to find the quotient if we only are asked to find the remainder. So this only proves that the theorem, remainder theorem, is correct because it also gave us the same remainder a while ago.